Hey everyone, welcome to another video. Today we will discuss a problem statement regular expression matching. Now let's go through the problem statement. Given an input string S and a pattern P, implement a regular expression matching with support for dot and star, where the dot matches any single character and star matches 0 or more of the preceding element. The match should cover the entire input string, not partial. So it means that we have this input string A, B and A star B. Now let's try to match this. So we have A, we have B, then we have A star B. So this matches with this A, and then in the star we have star. So it means it can be 0 or more of the preceding element. So let's assume that we use one instance of A. So it will become AB and it matches with the string AB. Now if we take another example, let's suppose AB and C A star B. So it will be, if we use one instance of A, it will be C A B and it will be AB. So it won't match. Now let's take some another example. The string is S and or let's suppose the string is AAB and the pattern is A star B. So if we take the star as one occurrence, so it will be AB. If we take 0 occurrence, it will be just B. If we take 2 occurrence, it will be AAB. So if we take the 2 occurrence, then it will match with the pattern. So in this case also, it will return the true element. This is our problem statement. Now let us think about the approach. The approach is that we take both the strings, let's say AB and A star B. We start with the first character and check if it matches or not. If it matches, then we will send the remaining substring to match. So if we write in the function of f of n, so if f of n, we have to check that if my f of 1 matches or not, and if yes, then we check if my f of n minus 1 is match or not. So it's not plus, it's like an AND condition. This seems to be a recursive approach, and we know that the recursive approach can be converted to a dynamic programming approach, DP approach. So what we can do is we will take a 2D array. Let's take a 2D array of n cross m size. Now n is the length of the given string S, which is like a AB, and m is the length of the pattern P, which is the length of A star B. And we'll take the matrices n plus 1 comma n plus 1. So it will be our 3 cross 4 of matrix for this example. So we'll just make this matrix. Now we'll start filling the table. Now the very first element, the 0 0 represents when both strings are empty. So if both strings are empty, then it's a match. So we'll put it as 1, which is true. Now if my I equal to 0, it means that the string S is empty. So which kind of pattern will match? Either an empty pattern will match, or if my dot star pattern will match, right? I can see that if on my even positions, if there is a star like A star, B star, C star, if on even position there are stars, then it will match to the empty string. So for the even positions, we will check, and odd positions, we can simply say that they will not match because it is an empty string. So it's 0. If even position it is a star, then we'll put it as 1. So in our case, this, yes, we have a star on the even position, so it will be 1, and then it will be 0. For example, this is A star B. So when j equals to 1, it is at A will not match with empty. When j equal to 2, it is at star match will match with the empty string, so it's 1. J equal to 2, we are at B will not match, so it's 0. Let's move on to filling this table. So we'll start with I and j, I equal to 1 and j equal to 1, and let me write the strings as here, AB, A star B. So if when I is equals to 1, so we are at this pointer A and A, or for better understanding, let's write as S and P. As S denote the string and P is the pattern. When I is 1, J is 1, the value of S is A, P is also A. They'll match. So I is 1 and J is 1 here. Now when J equals to 2, so S is A and P is star. So star will not match with A, but we need to check the preceding element of star if it is the case of star. So if it is star, we check the preceding element, and there can be two cases. Either we take the 0 occurrence or we take one or more occurrence. So if we take the 0 occurrence, so we'll just remove this and check if this element, the element which is before the preceding element, this one here, matches the ith element. So these is all zeros, and whether this or, so this is the 0 occurrence and the 1 occurrence is the preceding element. So preceding element matches, so A matches with the A. So 0 or 1, so it will be 1. Then we'll go to J equal to 3. So I is still 1, J is 3, which is B. So B does not match with A, so it's 0 here. Now we'll change I equals to 2. S is now B and P is again A. Now B and A will not match, so it will be 0. We'll move on to J equal to 2. S is B and P is star. So, okay, now we'll check whether my J minus 2, which is the, if we skip the previous element, whether this matches or not. No, so it does not match. So here it is 0. And does my preceding element, preceding then star, this one matches with this element or not? It also does not match. So 0 and 0, 0. Now next come on to the 3. So it's still B and it's B. So when B and B matches, it will become 1. And our final answer will be the value at the last row and column cell, which is this one, which is true, and it matches the expected answer. Now we'll write the code for this solution. So here's the code for the solution. We have taken two strings S and P. N is the length of S string, P is the length of the pattern string. We created a DB table with n plus 1 and n plus 1 size, and initially when both the strings are empty, we set it to true. We initialize the first row when the input string is empty and the pattern have star on the even places. If they have star on the even places, then we set those to true values. Now we iterate over the array now, starting from the first character, which is I equal to 1, J equal to 1, and we iterate till when I is n and J is till m. We take the current character, we matches the current character. If the current character matches, or the pattern is star, because as per the problem statement, the star can match with any character. So if this is the case, then we assign the value of I comma j to the whatever the value of was there in I minus 1 comma j minus 1. So think of it as this function. My I comma j is, so f of 1 is true because it matches. So this does not, we don't have to write this. I comma j will be I minus 1 comma j minus 1. That's how. Now moving on to the else part. So if it does not match, and we check if the pattern is star or not star. So if it is star, then there are again two cases. Either there will be 0 occurrence. So we do not take any occurrence of the element which preceding element of star. Then in that case, our answer will be I comma j equals to I comma j minus 2. Basically, we skip the element. And if the previous element matches the current element, so this is the case where one or more occurrence matches, or the previous character is star, again the same condition, then the value will be dp of I comma j, basically if the 0 occurrence or one or more occurrence, and this will be stored in the dp. And similarly we'll iterate over the loop and this function will get completed, and finally we return the last element in the last row and the last column. So coming on to the time complexity part. The time complexity will be, there are two loops. The first loop is going from 1 to n, and the second loop is going from 1 to m. So O of n cross m will be the time complexity. There is one more loop here, which is this loop, which goes from 1 to m. So plus O of m, but since n cross m is greater than m, so the final time complexity will be O of n cross m. And space complexity will also be, since we are storing a 2D array, we are storing elements in a 2D array, it will again be O of n cross m. Sorry, n cross m. Alright, so this is how we solve the regular expression matching problem. Thank you for watching the video. Have a nice day.